Hi there and welcome back to Triplicate, home of interesting electronics. And after a pretty hectic Christmas and New Year, I haven't managed to do much videoing, so it's now the New Year and I'm back on it. Over Christmas, well for Christmas, I did get a new, you see that, a new light to use on my videos. Let me fire this up. Yeah, that's going to really upset the camera. There we go. So we'll do warm white and cold white, and it did have a mount here for a phone, so I'm in the process of making a mount for my video camera. So I don't have to light videos with my magnifier light. Clunk. Okay, a few of you have been leaving comments on my videos, for which many thanks. I've been trying to reply to them, but something weird has happened to YouTube and it doesn't seem to let me reply to them, and it seems to lose the replies I've made. So apologies, I am trying, and I am going to make a big effort, a New Year's resolution to keep track of the channel more and keep up with the comments and replies and so forth. What else? Oh yes, and the light up advertises, so the box it came in, Beauty Live ring light. So as you can tell, my appearance has improved no end. Not. Okay, so we're back on the radio controlled lorry, the big rig, and I made an executive decision because, as I say, I'd not moved on with anything over the holiday period. I made a decision to press on with a few things, a few of the less exciting preparatory things, off camera because it's quicker and not so interesting to watch anyway. So I have let's see if I can pick this up without wrecking everything. Cut a rather ugly hole in the back of the cab into which the connector goes, so we can unplug the tractor unit from the cab. I've also, which has got tangled up with this, put a connector of sorts between the LEDs that go in the cab and the main unit, so I can pull the cab off if I needs be. And I, unfortunately, having cut the hole in the back, discovered that this thing, which goes there, can we see that, blocks the bottom of my hole, so I'm going to have to chop some of this out of the back of here. Hey ho, so it goes. So I've also prepared a socket which just has the pairs of pins soldered together, so I can check that my wiring to my socket is good, and I have tried this, so hopefully it should work. So we've got batteries in it, I've turned it on, yep, the little lights on the roof flash, and if I hold it off the ground, yeah, you can see the front wheels are turning and the back wheels are spinning. and the lights are coming on the front for what it's worth. I might end up having to do something with those lights. Oh, there you go. So that's that. However, I also did, after I made the last video and thinking about it, I'd made a bit of a mistake, which I shall now share with you, which did mean I had to do a small amount of rewiring and recoding, but it's an interesting point, so I will go over it with you. Okay, as it's wired up now, we're using PWM. That's turning the output on full, on and off very quickly to drive the motor, and the amount it's turned on relative to the amount it's turned off controls the amount of power to the motor. So currently, when we're actually driving the motor, we have, say, C equals high and D equals low if we're going forward. Now, the way it was originally wired up, when the PWM was off, we had this situation. We were using driving C and D for the PWM, so C equals D. Now they've called it fast motor stop because in this case the motor is actually shorted across through the driver chip. So if the motor is turning at this point, the back EMF from the motor is driving current through the motor windings and heating them up and wasting the energy. This is not what we want. So what we actually want to do is use C and D just to select the direction of the motor and use the enable pin for the PWM. So when it's high, it's driving current through the motor, say C equals high and D equals low. And when the PWM is off, the enable is low, the motor is free running and won't lose any energy. Okay, so here's the revised circuit. If we look here, I've had to move two of the inputs to the motor driver. That's so what was D9 and D10 go to D11 and D12, enabling D9 and D10 to be used for PWM because D and 11 and D12 are not capable of PWM. What else have I done? Right, I was originally going to use the battery compartment in the truck to house half the batteries and a separate battery case for the other half. But this would cause problems when it was turned off with with current being driven backwards through the remote control circuitry. So I abandoned this idea, and now we have two battery holders in the trailer producing 12 volts nominal, and we have a 5-volt regulator which is producing a voltage to drive the remote control circuitry. I could put a diode in here to up the voltage a bit if required, but I think it should run at 5 volts okay. So let's see if our changes to the way we're driving the motors work on our little test rig. Last time I was waiting for two more of these to come in and they never did in the end, so I had to fit two of those, but anyway, it's a test rig, who cares. And what I've done here is I've taken, this is 5-volt line from the Arduino, and I've put that through a diode and used two 10k resistors just to bias each of these up to about 5 volts if there's no actual drive coming from the motor, This enables us to check that our motor driver is now doing what we want it to do. And don't know whether you can see this, but we now have two wires here and here, which are driving the enable lines to the chip. So, okay, I've supported this at an angle so you can hopefully see the LEDs with two scope probes. I've plugged the lead in and we're good to go. Okay, just the quickest peek at the code here. So these two digital write calls set the two motor outputs, one low, one high, depending on the direction, and we send to the enable line what I've called PWM value, which is 0 to 255, as I described just a moment ago. Okay, so we've got two scope probes on so we can see what we're doing on the scope. Pointed up so you can see the LEDs, using this high-tech bit of wood. So shall we fire the code down into the Arduino? There we go. Okay, we're running, so if we turn on the power, yeah, we've got power on the motor driver board. So let's just zoom in a little. So shall we see if it works? Well, I know it works. Right, so we can see that if I hold that button, that yellow LED gets brighter, and if I hold the other button, I realise you can't see because it's behind the cable, goes the other way and the green one gets brighter, and that's off. Same with this. The green one, the yellow one. So it's doing what it's supposed to do. It's driving current through those two resistors in two directions. What I did forget to say is when you press this button, it just increments or decrements the current between plus and minus a maximum value. We won't worry about this for now, it's just test code. Okay, so if we look at what's happening on the oscilloscope, so let's see what happens. Okay, so if we go that way, we can see, come on. Okay, the orange trace is at 0 and the blue trace is at whatever volts come out of the motor driver, and you can see here that while the power is not applied, it's just floating back down to this nominally 5-volt value, and you can see it floats down because there'll be capacitance in diodes around the circuit. So if I reduce it, okay, there we go, that's 0, and reduce it further, and now the orange is high and the blue is low. And again, when there's no power, when the PWM is off, it just floats back to 5 volts or so, a bit under.
So, do we think that's working? I think we do. So, is it time to try and make some motors to go round and finally have a bit of fun? I think it is. Okay, so here we are. I've got some code here where I've just disabled a motor for now, so we're just going to check the inputs. So we'll put that in the Arduino. Okay, seems to think so. That's okay. Now we're just going to bring the voltage up very gently onto the main board. Let's see. I'm going to pull that scope probe off and just upend this. So, there we go. So that implies that the RF board is working okay. Let's clip that scope probe back on. Can you still see? You can still see. And we'll wind up to maybe 9 volts. And okay, if I get the controller, we have a controller, and I turn on the monitor. Well, that needs some investigation. We've got 3 inputs on. Okay, so the speed, let's see if I can get this in shot. A bit prototypey this. So the speed, if we look at these left 2 ones, if neither's pressed, they're both high. One's pressed and the reverse pressed. That's right. Unfortunately the steering, which I don't quite understand, it just leaves either one pressed. So am I pulling it from the wrong place? I might be. I shall turn you off and do a bit of poking around with the meter.
Okay, so a bit of poking about, and I concluded that the outputs from the remote control chip on the truck are designed to drive electric motors, which are essentially low impedance devices, and we are trying to use them to drive the Arduino, the inputs of which are pretty high impedance. So what I've done is put 4 resistors from here on the circuit diagram to ground, just to pull those down. They're 1Ks and they seem to do the job. And this is starting to get a bit hacky now. And put it back together. On the right way? Is that on the right way? It is. Okay, so I think we're good. Shall we connect it up to the computer again and see what it's like for reading the inputs? Okay, so here we are. It's running and it's
Our monitor's running, and these 4 dashes here show X when a button's pressed. So, shall we press forwards? Yes. Should we press reverse? That's good. Whichever direction that is on the steering, we get an X. And the other side of the steering, we get an X. We're good. So, shall we see if we can turn a motor or two? So this was the line I put in to disable the motors. I'll just comment it for now, and we will fire up this code with the motors enabled again, and we're good. Okay, yeah, and it's going well. So what do we reckon? We need more current limit. So okay, well, we definitely have something. Certainly the back wheels are going. Just because I have no idea what speed it should be going, I'm going to modify the monitor to display for each motor PWM output and current input, so we can get an idea of what's going on. And when I've done that, I'll bring you back. Okay, so I've just changed the printout here. So again, the first 4 dashes are what the 4 switches are doing. Then there's the supply voltage. Then M0 is which motor I can't remember. M1 is the other motor, and the first number is the PWM value across it, and the second number is the current. So shall we M0 is the back wheels, and this is a bit in the way, and you see it's singing. We know it's got PWM across it, but the wheels aren't turning. And if I give them a little poke, they do, so that's an interesting problem we might have to address. But apart from that, there we go, that's going forwards. It's off, backwards, it starts there. It's going backwards, you can take my word for it. Okay, so that works, and the steering, I'm just looking, remove that Well, I hope you can see it. There we go. Okay, so it's working. It's not exactly smooth, but that's next week's problem. So I think I'm going to call time on this particular video. We've got quite a long way. We now can drive both the steering and the power wheels from Arduino, which is what we want to do. So next time we can pick it up and start trying to get them to do what we want them to do. So hope you've enjoyed it. Subscribe if you find it interesting. Thumbs up perhaps. Leave a comment and I'll try and figure out how to persuade YouTube to reply to them. Let me reply to them. Until next time, it's goodbye from Triplicate, home of interesting electronics.